Hello, it's Mrs. Hayford, and this lesson is solving one-step equations with division. Today I've decided to use some food that is not going to tempt me to eat it, so my X's today are farfalle, bow tie pasta, Annabeth's favorite, and I have put negatives on the other side in case we do negative X, which we're not going to do today, but we will in the combining like terms lesson, which comes next. So when I look at my equation here, I see x divided by 2 is equal to 3. Remember, the fraction bar is the same as the division side. So if it helps you to remember it by writing it the way you first were introduced to division, x divided by 2 equals 3, you can write it that way. That might help you think about it as you're solving. This is kind of hard to represent because since we don't know what x is, how can we divide it by 2? So what I've decided is I'm going to use my variable x here, and I'm going to show that it's being divided into 2 parts. I'm just going to slide 2 pieces of paper underneath to show that this is really going to be divided into 2 equal groups. How do I know they're equal groups? Because I'm using the same size paper, and we know that division is equal sharing. So x divided into 2 groups gives me a result of 3 is equal to 3. And I know I've been saying you do the same thing to both sides, you do the same thing to both sides in equations, and that's true. But the trick with this is that we already know what one side is equal to once we've done the division. We've got to work backwards. We've got to think about, well, if this is what it's like after the division, how can we find out the total before it was broken into parts? So all you're going to do is you know that one of these groups is equal to what's on this side. So I'm going to put 3 pennies in each group because I know that one of these groups is equal to this side. And what do you see? You see that all together, this x is worth 6. Right? So that's kind of confusing to think about. It's the trickiest one to show with a model, although when we do the algorithm, you'll see it's not actually that tricky if you think about your inverse operation. So my model, the way I'm going to represent it, is I'm going to show x divided into 2 groups, and that was equal to positive 3. And we know that we are just taking these 3 and putting them into each group. My marker got broken a little bit, so it's kind of hard to read. And we know that 3 and 3 go together to make a total of 6. So we know that that x is equal to 6. What that looks like in the algorithm, and this is where we can use our inverse operation rules. What we do to one side, we have to do to the other. Well, I know that the opposite of dividing by 2 is multiplying by 2. So I'm going to multiply by 2 on that side and multiply by 2 on this side. 2, and I can put my 2 over 1 so I don't get confused. 2 times x is 2x. 1 times 2 is 2, and that's equal to 3 times 2 is 6. And why that works is because any number divided by itself is 1, so this 2 divided by 2 becomes 1, so I'm really left with 1x, which is equal to 6. And since this one was kind of confusing, I want to make sure we really go back and do our check. We can substitute our answer for x back into the original. We had x divided by 2 equals 3, so in place of x, I'm going to write 6 divided by 2 is equal to 3. And if you think about that the way you first learned division, it looks like that, which is true. 3 is equal to 3. So it checks out. Okay? All right, let's practice that again because it is a bit confusing at first, and hopefully the more we do it, the easier it'll be. And hopefully you'll move toward using this inverse operation because then we can follow those rules using properties of equality. All right. Slide up a little more, clear off my mat here. And this one for B, we see x divided by 4 is equal to 5. So I'm going to start with my x. And this time I know that x is being divided into 4 equal parts. So I'm going to represent it with 1, 2, 3, 4 equal groups here. My x has been split into 4 equal groups. And I know each of those equal groups is worth 5. Okay? So if each group is worth 5, then I need to represent 5 in each of the groups. Okay. What could that look like on my model? And this is where it's a little tricky because it doesn't exactly match up with what we were doing earlier. We have our x divided into 1, 2, 3, 4 equal groups. And we know each of those groups has 5 in it. 1, 2, 3, 4, 5. So I'm going to put 5 into 1 group, 2 groups, 3 groups, 4 groups. Each of those groups has 5 in it, which gives us a total of 5, 10, 15, 20. X is equal to 20. For our algorithm, we think about x being divided by 4. Well, the opposite of division is multiplication. In order to get 1x, I need to multiply by 4 over 1. If I do that on one side, I have to do it on the other so I don't go to math jail. Then I end up with 4x divided by 4 is equal to 20. And we know that any number divided by itself is 1. So 4x divided by 4 is really equal to 1x, which is equal to 20. And I can check it out by substituting 20 divided by 4 is equal to 5. And when I do that division out, 20 divided by 4, we know that's actually equal to 5. So it does check out. Okay. And the last practice problem we're going to do before I give you some time to work on your own is x divided by 3 is equal to negative 1. I'm going to set it up on our mat. We've got x here. Got 3 groups, 3 equal groups that x is being divided into. Okay, it's being divided into those 3 parts. And each of those parts is equal to negative 1. So I'm going to take one of my pennies, turn it over tail side up. And remember, whatever is on this side is the value in each of those equal groups. So I'm going to fill my equal groups with that. And you can see that negative 1 and negative 1 and negative 1 equals negative 3. In my model, we've got x broken into 1, 2, 3 groups. This time we've got a negative number, negative 1 represented with red. And we know that that's going to transfer into each group. Negative 1, negative 1, negative 1. 3 groups of negative 1 gives me negative 3. Using my inverse operations, we have, and I'm going to show you this in a different way because there are 2 correct ways you can show it, and this might make more sense to some of you. X divided by 3, well, to undo that dividing by 3, we're going to multiply by 3. And negative 1, if I multiplied by 3 on this side, I need to multiply by 3 on this side. The 3 divided by 3, or dividing by 3 and multiplying by 3, you'd still get 1. Anyway, those cancel out. We've got x is equal to negative 3 over here. To check it, I substitute negative 3 in for x. Negative 3 divided by negative 3, or excuse me, negative 3 divided by 3 is equal to negative 1. And that is true. Negative 1 is indeed equal to negative 1, so it checks out. All right, give these a shot, and I will go ahead and reveal the answers in a new video. Ooh, a new video that's the answer key. So go ahead and pause your video here, practice those problems, and then click on the next video to check for an answer.